Hello and welcome to Lesson 2.2, Polynomial Equations and Inequalities. In order to do this one, you're going to need to know all your concepts about polynomial functions. So first off, we're going to start by cutting out square corners from a 30 centimeter piece of cardboard by a 20 centimeter piece of cardboard. So I'm going to draw what I mean right here. So let's say we have a piece of cardboard like this rectangle. This length is going to be 30 centimeters, and this length is going to be 20 centimeters. We're going to cut corner pieces out of it like this, from these corners right here. And we're going to fold along this line, along this line, along this line, and along this line to make an open top box. Well, if these corners are each considered x, then this distance would be 30 minus 2x, because we take off an x here and an x here from 30. Likewise, this distance would be 20 minus 2x. So what we want to do is we want to calculate the dimensions of the box with a volume of 1,000 centimeters. So to figure out the volume, first of all, volume is going to be given by the length, which is 30 minus 2x of the box, times 20 minus 2x of the box, which is the width, times the height, which is going to be given by the variable x. Now we want this volume to be 1,000. So we're going to put 1,000 in on that side. And now we get a polynomial equation. Again, it's much easier to solve polynomial equations by actually setting them equal to 0. So that's what we're going to do, set it equal to 0 by subtracting off 1,000 off both sides. So from here, what we're going to do is we're going to expand. Going to continue to expand. So now I'm going to get 4x cubed minus 100x squared plus 600x minus 1,000. Now it's going to be easier to factor this if we can actually divide everything by 4 first. So if I divide everything by 4, I get x cubed minus 25x squared plus 150x minus 250. Okay, so in order to figure this out, I'm going to let f of x be this function, x cubed minus 25x squared plus 150x minus 250. Notice if you substitute the value 5 in, it gives you a 0. So that's what I'm going to do. I am going to synthetically divide 5 into this expression so I can find my other factors. Again, review your synthetic division skills if you've forgotten how to do this. Okay, so now this means, therefore this function is originally now x minus 5 times x squared minus 20x plus 50. Well, that means there are two possible zeros here. One possible zero is x equals 5. Another possible zero, because this can't be factored, I had to use a quadratic formula to solve this one. Okay, so here I get two values, approximately 17.071 and another possible value of approximately 2.929. Well, remember that our original question had lengths of 30 minus 2x and 20 minus 2x and a height of x. Well, negative values wouldn't be allowed in this case, which we don't have here, but neither is the 17.071 allowed. The 17.071 would actually give a distance or a length that's a negative value. So the only possible answers that we could have here are 2.929 or 5. So here's our possible solutions. So if x equals 5, then we have 5 centimeters by 10 centimeters by 20 centimeters, just by substituting back into our values. Or another option is if x was equal to 2.929, then it's 2.929 centimeters by 4.142 centimeters by 14.142 centimeters. And these are the possible solutions. Okay, so let's take a look at another problem. This one's going to be an inequality that we're solving for. So again, to solve these kinds of things, first set one side of the expression equal to 0. So what I'm going to do is I'm going to bring everything to one side. I'm also going to start organizing some of these values while I'm doing this. Okay, so this now simplifies to 36, and this is negative 9x, and this is minus 4x squared, and an x cubed. This is all greater than 0. Oops, let me fix that cubed. Doesn't look like a 3. There we go. Okay, so again, we could factor. Now this factor actually turns out to be a little bit easier. You might notice that you have a common factor between the first two terms and the last two terms, like x squared, which will leave me with x minus 4, and negative 9, which again will leave me with x minus 4. This doesn't always happen, but in this case it worked out. So now I can common factor out the x minus 4s, and I'm left with x squared minus 9. Or, if I wish, x minus 4 times x plus 3 times x minus 3, which is greater than 0. Because, again, we can factor the x squared minus 9 into x plus 3 and x minus 3 by difference of squares. So what we're interested in here is when this entire expression is greater than 0. Well, we know when it is equal to 0. We have zeros for this. We have zeros at negative 3, at positive 3, and at positive 4. So what we can do is we can analyze this function in between these values to see whether or not it's positive or negative. Now, commonly what we did last year was we constructed what was called an interval chart. So we looked at values of x less than negative 3. We looked at values between negative 3 and 3. We looked at values between 3 and 4. And x values greater than 4. We wrote our factors along the side, whatever factors we had, including constants and negatives or positive values. And again, we were interested in whatever this result turned out to be. We're again interested in our result being positive, greater than 0. So again, you choose values between less than -3, and you substitute in for each of the values. So I'm going to choose like -4, substitute it into x minus 4, I get a negative. Substitute into x plus 3, I get a negative. Substitute into x minus 3, I get a negative. A negative times a negative times a negative gives us a negative result. So try this out on your own and fill out the rest of the chart. Now please realize that this doesn't always occur, that it switches between negative and positive. Sometimes it actually goes from a negative to a positive, or vice versa, a negative to a negative to a positive. Don't assume. So therefore, this x minus 4 times the x plus 3 times the x minus 3 is greater than 0 when, again, we're interested in positives. So an x is between -3 and 3, or when x is greater than 4. Which you can also draw a sketch of what this function would look like if you remember. Well, again, our zeros are at -3, 3, and 4. Because of the shape of it, it's got a positive leading coefficient, so it's probably looking something like this. And this is where it's positive, and this is where it's positive. Looking at those, you can see where the domains are. So you can use this interval chart. You can also use this sketch to help you figure this out. Okay, so let's try one last problem. This one is a little bit easier as it is already given a graph for us. So we want to solve this graphically. Well, first of all, the function x cubed minus x squared minus 3x plus 3 is given by this function right here, must be, because this is the leading coefficient is positive. And therefore, also the y-intercept is 3. Therefore, this must be y equals -x cubed plus 2x plus 5. So, we're interested in when the rad function is smaller than the other function, the blue function in our case. So you have to find out when the rad function is lower on the x-axis, lower on the y-axis, and the y values, than the blue function. First, find where they're intersecting. They intersect at x equal to -1, at x equal to -0.5, and also at x equals to 2. These are the key locations that you're interested in. Now, find where the rad function is lower than the blue function. I'm going to highlight those areas. This area is where the rad function is lower than the blue function. this area is where the red function is lower than the blue function. So those are domains of x less than -1 or values between -0.5 and 2. Please realize if any of these inequalities were equal to signs, just like the original first question, you'd have to change the inequalities to equal signs. Or if this was a less than or equal to sign, then these signs that you have here as your solutions would have been less than or equal to signs as well. And thus concludes lesson 2.2.